Okay, so so we will go to we will introduce the next topic T12, which is network. Okay, which means in network security. Okay, we will have a lot of different data. Okay, to be collected, to be monitored. Network packet is one of the data which is very important because it carries all the attacks. Okay, we provide usually your company, okay, or your computer provide a lot of different network services. For example, web services, email services, something like that. And hackers, okay, will try to compromise our system, okay, but they are somewhere, okay, in the internet, okay, so they have to remotely hack your system, okay, by using certain network protocols, okay. So network packet is one of the important data set that help us to analyze the current status of your network, okay. So that is the topic 12. Okay. Before we introduce the network analysis, okay, next week, okay, April 22nd, okay, is our midterm. We have no class, so you don't have to come to here, you don't have to online. But we don't have midterm, okay. Our midterm will be like longer, more complex homework. So we will announce this longer, complex homework, which is our midterm, in our website. So you will have a longer time, maybe 2 or 3 weeks, to finish this midterm at home. And of course, you can find some textbooks, you can find network document, you can use different Python package help you to finish your midterm, okay? Or you can refer our slides, okay? It will have a lot of codes which can help you to finish your midterm. But basically, you cannot discuss with your classmate, which is not allowed, because we hope you can finish this midterm on your own, okay? But you can ask questions on our forum, okay? If you don't understand which, for example, what exactly this question meant to be. So you can ask questions in the forum. Tia and I will help you to understand what you should do for the midterm. And basically, you don't need, okay, you don't need and you cannot ask questions to your classmate, okay? We wish you complete this midterm by yourself on your own. So that is midterm. You don't have to come to class. We don't have any online streaming next week. So we will announce the midterm on our website, and maybe 2 or 3 weeks you finish the midterm and send it to TA before due time, okay, due date, okay. Okay, so let's go to T12, okay, which is network capture. But before we introduce these things, first we have to make sure you understand what is a packet. So here we have another nothing's right here, okay. Basically, okay, if you are a student of MIs, okay, basically I believe you have learned you have enrolled some network related course, and in this course we will teach you how to capture packet, okay, from your laptop or PC. So basically we have a tool called Wireshark, okay? And this tool, if you install this tool in your laptop or personal computer, okay? When you connect it to your network, no matter by using wireless network interface or wired interface, which is Wi-Fi or Ethernet, okay? And then you can install such kind of tool, okay, Wireshark, to capture all the packet that pass through your network interface card, okay, so that we can collect those data, okay. And okay, maybe you know that, okay, in such kind of Ethernet, okay, which is your LAN, local area network, or your Wi-Fi, which is a wireless local area network, okay, you can sense all the packet transmitted in this media, okay, no matter this packet is transferred from you or to you, or even from other interface to other interface, okay, no matter this packet is transferred from you or to you, or between any other interfaces in this media, you can capture them, okay. So that is a very powerful tool. So basically, we will install such kind of monitor, okay, at the gateway of your company, okay, so that at this point, at this location, we can capture all the traffic, okay, network traffic from your company or to your company, your network, okay. So basically, we will install a monitor at the gateway so that all the traffic from your company or to company will be captured at the gateway by using those kind of tools. So after that, okay, we have some inbound traffic and outbound traffic from the perspective of your company, okay. So usually, okay, we will analyze those inbound traffic because those traffic are from outside of your company. They may try to invade your computer network, okay. 好，中文就是说，我们通常会在网络的 gateway 上安装这样子的 monitor， 然后去 capture 来自于你公司或是来或是去from 或 to 你的 company。那我们就会把 traffic 分成 inbound 跟 outbound 嘛，就是从外面进来到你的公司叫 inbound 嘛，对不对？从你的公司去外面叫做 outbound， 对不对？我们就会分析这些 inbound 的 traffic 看那个外面的骇客是不是想要攻击你的公司里面内部的那些伺服器就是会分析。那风暴就是一个一个一个的嘛，对不对？所以就是像一个一个，那它有点像序列，所以我们就要想办法去分析说这个风暴到底是好风暴还是坏风暴，有没有企图想要攻击等等之类的，就是类似像这样。Okay, so on the screen, okay, there is an example that I download from some analyzed website. Okay, it says it is a malicious. There are a lot of malicious packet. Okay, in this packet data set. Okay, so basically it reads as 1 to 62. So there are 62 packets in this data set. Okay, so that is the time information. Okay, from the very first beginning to 28.58 seconds. Okay, for a packet, of course there are there are source IP address. Okay, this packet is from 10.1.10.53 to its destination 84, 54, 22, 33. Okay, and of course, okay, this packet has 975 bytes in this packet, and of course it's layered. Okay, as if you have taken a computer network course, okay, you know packet is layered. Okay, it is Ethernet packet. Okay, encapsulate is IP packet, UDP packet, and it's DNS packet. Okay, so you can see that we have different layers: information, source, destination, IP information, time information, protocol information, UDP information, port numbers, checksum, payload number, payload size. Okay, and so on and so forth. Okay, at the end it is a DNS packet. So it is a DNS packet. So it is a DNS query. A lot of different information right here, and so on and so forth. So that those information are very important. So that maybe we can extract some field, some values from this packet to create our table, so that we can further feed those table into machine learning algorithm to help us to identify if it is a normal DNS packet or it is a malicious DNS packet, so on and so forth. Okay, so basically that is the packet that we can capture from the network. Okay, so let's go back to the our code. Okay, so pcap means packet capture. Okay, so we have a lot of different tools can help us to capture those packets. So how do we analyze those packets in Python? Okay, so here is that. Okay, I provide some packet as an example. So first you have to download the example that I provide, which is called suspicious.pcap. Okay, you can simply just download it from my Google Drive. Okay, so then make sure you have this data. Okay, this data. So so that is okay. So next you have to install a package, which because packets, okay, pcap files, okay, they are packets, okay, and packets are binary files. They're very similar to PE files. Okay, a lot of binary packet will be concatenated together and form a pcap file. So usually pcap file contains multiple packets, and these packets are binary format. Okay, and they will be several different layers, okay, in a packet. So basically it's very similar to PE file. There are several different sections, there are several different headers that you have to parse. However, with the help of these packages, we don't have to parse those headers by ourselves. So we can easily use these packages. So please install this packaging. Okay, and then okay, let's try to do something. Okay, first, okay, after you install these packages, okay, you can sniff. Sniff means if you install these packages, okay, this package in your own computer, not collab, okay, in your own computer, and then you simply just need to do this. Sniff count, for example, 100, and then this package will control your network interface card and try to collect at most 100 packets from your network interface card, and most likely it is the Wi-Fi, your Wi-Fi network card. Okay, so in this file, in this instance, pcap, it contains 100 packets. Okay, you can do it in this way. Okay, but if you execute this code on Colab, It means this code will capture the machine of the collab, and we'll try to figure out which is the main network interface card on that collab machine server, and capture 100 packet on that collab machine. Okay, so if you like to try this code, basically I recommend you capture the packet on your own laptop, which means you run this code by use your own laptop and on your own Python Jupyter notebook. Okay, if you run this code on the collab, that means it capture the collab's packet, collab machine's packet, which might not be that meaningful. Okay, when you analyze those packets. Okay, so basically that is okay. So, so currently pcip, this variable means it is a 100 packet. Okay, so basically we can type this variable, and it's okay. It is scapy. Okay, means capture Python. Okay, and it is a list, packet list. Okay, it is data structure. Okay, this data structure is a list, and it contains 100 packet. Okay, so the length of this instance is 100, and for okay, you can print it. You can print this pcap object, and this object is simply like this. Okay, so what is inside this list? Okay, so you can use type. Okay, so it says okay, it is another object, and this object is scpy layers L2 ether. It means the first packet that we capture, okay, is our Ethernet packet. Okay, and its value is right here. It's the B, means it is a binary array. Okay, so you can see that here is the binary array. Okay, you can print it, but it is meaningless because it is layered. So basically we recommend. So basically we recommend you have to do parsing first. Okay, so the next one is how do we do parsing? Okay, so basically this package provides a very useful function called show. So basically you can use the show function to print all the packet. Okay, so you can sniff. Okay, you can sniff to packet. Okay, so for each packet, okay, I'm afraid you have to learn how to use the lambda function by yourself. Okay, so basically you can show each packet in this way. So basically it will print the file in, where is it? It's right here. The first packet is right here. The first packet is right here. Okay, it will print the layered information of this packet as we seen in the workshop, right? So the first is the Ethernet. It has a destination MAC address, which is 02 blah blah blah. The destination MAC address 0242 blah blah blah, and its type is IPv4. So the next layer will be IPv4 headers. Okay, so right here, version 4. Okay, header length 5, which means it's 20 bytes, and the TLS means quality of service, type of service. Length, ID, flag, blah blah blah. So basically, all the field will be parsed by the package itself. So we don't have to parse them. Okay, so we can simply just pick which field might be important for you to analyze this packet, so that we can differentiate malicious packet and benign packet. So you have to pick the field, but which field are more important when we do such kind of analysis? Basically, those are domain knowledge. So you have to know what exactly each field means. If you forget those meanings, so go back home to find your computer network textbooks. Okay, it will describe. It will have a table. Okay, tell you which column. What exactly it means. Okay, it for each field. Okay, so that is the things. Of course, it has some raw data in the, for example, in the right here. Okay, basically, I think the file, the example right here, it is a HTTP packet. So their 7 content is capital GET, okay, / socket.io, something like that. Okay, I believe you are familiar with HTTP protocol. Okay, so that is the first packet. Okay, that is the second one, and so on and so forth. Okay, so basically you can do that. Okay, there's another way to print it out. Okay, so basically you can print the packet by the summary function. Okay, the summary function will give you a summary, right? Where this comes from? Okay, from IP right here, and its port number, it's the direction to the destination, and it is the destination port, something like that. Or you can customize your print function, okay, the string print function, so that you can print it in whatever you like. Okay, that is okay. Right here, there are several different modules, okay, by scapy. Okay, so let's take a look at this scapy. Okay, and you can go to the document of this package. So in this document, it teaches you how to capture packet, how to analyze packet, which we will cover later. But there is a very important thing, is that there are several different modules that there are several different modules. Where is it? There's several different modules provided by this package, so that you can simply just invoke those functions. Okay. So maybe we can do some change right here. Okay, let's take a look at the code, okay, which is good enough. Okay, for example, there's a module called P0F. Okay, it stands for profiling. Profiling what? Okay, that means this one, passive OS fingerprinting. Okay, that is right here. Okay, that is usage. That is the usage. Okay, so that we can do search right here. P0F. Right? Okay, as you can see that. There are several different modules, okay, that already implement those modules. So you simply just include them, for example, right here. Okay, you can see the green, the orange line. Okay, load module P0F. That means I would like to load this analysis module. Okay, at the bottom side there is a packet P, right? So you can capture one packet, which is P. Okay, and you can see the information is right here. It's an Ethernet packet and blah 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 blah. Okay, and you load this module P0F, and then you put the P0F to you analyze the packet P, by using P0F, and it says 1.0 Linux 2.4.2 blah blah blah. That means if you analyze the packet by using this very useful module, and it tells what operating system that transfer this packet, submit this to create, okay, to create this packet P. That is a little bit amazing, right? By analyzing a packet, we can know this packet is transmitted by a specific operating system. For this example, it's a Linux 2.4.2. What does that mean? Because for each different operating system, when they construct the packet, okay, different no matter which layer, okay, layer 2 Ethernet, layer 3 IP layer 4 TCP or UDP. When they construct those packets, okay, there are certain parameters which is a little bit different operating systems by operating systems。中文再讲一遍哈。这个看起来有点神奇哈，就是你给它一个 packet P 嘛，然后你载入一个 module 叫 P0F， 你叫 P0F 去 analyze 这个 packet P， 然后它突然就会跟你讲说，这个 packet P 啊是从一台 Linux 2.4.2 的机器发送出来的。好，这听起来有点神奇啊。原因是为什么呢？当我们的作业系统在 implement 的时候啊，因为作业系统要负责 Layer 2、Layer 3、Layer 4嘛，对不对？Layer 7是 program 自己做的嘛，对不对？啊 ，program 把封包发出来之后，接下来下层就是 Layer 4、3、2，对不对？好，那我们 capture 之后呢，432的这个封包的组成哈，比如说construct 哈，创建是由作业系统做的。那作业系统在 implement 要把这些封包组起来的时候呢，不同的作业系统 Linux、Windows、Mac， 他们都会有一些些许的不同的参数的不同，而这些些许的不同会导致于他们做出来的封包某些栏位上的值会有些许的不同。比方说，在 Layer 4里面的 TTL 里面 ，Windows 设定的初始值跟 Linux 设定的初始值跟 Mac 设定的初始值就是不一样的，所以你有的时候可以用猜的去猜出来说这个封包是由哪一个不同的作业系统发出来的啊，因为 implementation wise 上会有些许的不同。好，那这些不同怎么判断？不管了，反正 P0F 这个 module 人家已经帮我们写好了，好，里面有各式各样的判断规则，所以就用它吧。好 ，So let's go back to our code, okay? So basically there are a lot of rules that can help us to specify which operating system that this packet belongs to. So, however, sometimes this module is not available. So I write the code right here. Sniff one packet and use the P0F module to analyze this packet. So sometimes it's not workable. Okay, but basically you can run this code on your own computer because Colab does not allow us to do such kind of analysis, so that is not workable on Colab. But sometimes in your own laptop, okay, it is workable. It can recognize what operating system this packet belongs to. Okay, so that is okay. So that is just one of the modules. Okay, so basically we can collect, we can sniff different packet, we can download packet from different website. Okay, we will show you later. Maybe we can do it right now. Okay, so here here in week number 8, right? So here are some PCAP samples from www.netresources.com. Okay, reset.com, and there will be a lot of pcap files captured by different experts. Okay, and they will and you can download those traffic. Those traffic, most of them are malicious traffic, as you can see here. Okay, so basically there are different resources. Okay, for network forensics. SCADA, you don't need this. SCADA is another network used by industry. Okay, we don't use this network. Okay, and there are some packets, okay, from DEFCON, which is a security conference. Okay, packet injection. There are a lot of, so you can download one of them. Okay, and use this packet to analyze, to do the further analyze. Okay, so for example, okay, we currently have 162 packet, okay, in pcip, this object. Okay, so first things we have to know this TCP field, right? How do we use Python to analyze this kind of data, right? So first thing is right here. We select one of the packet, for example, the pcap 101, and then take a look at this one from here to here. Okay, if we like to obtain the payload of this Ethernet frame, we simply just use this name dot, right, payload, and then Ethernet is there too, right? So its payload is there 3. So its payload is a IP packet. So for the IP packet, its payload is there 4, right? So we said it's a layer 4 segment, and layer 4 segment, its payload is layer 7, which means it's a message. Layer 7 message is a data. So basically, okay, make sure you understand how packets are layered, right? So that you know, you can understand that in this object, okay, this single packet is layer 2 packet. Layer 2 packet's payload is layer 3. Layer 3's payload is layer 4. Layer 4 payload is layer 7 message. So it's quite simple because all the things has been, all those packet has been parsed by this package. So you don't have to parse by yourself. You simply just know how to retrieve them by using payload. And further, for each packet, for each layer, you can invoke summary function, so that it tells you the following information. Okay. Okay. Or you can simply just dump all the information. However, those information is very nice for human beings to read this information, but those information are not good for Python to analyze, because they are just a bunch of text. For analyze, we would like to analyze those text information to some integers or to some other data structure. So text is not good for analyze. So we have another. You can dump, okay, the one packet. However, we simply just see the hexadecimal information of this packet, which is not which is a little bit useless, right? So there's another function called ls, okay, which is quite human readable, but that is not good enough, right? So further, where it's right here. You have to import even more libraries, okay? So help you to convert a binary pcap file to a data frame, which is a table. So basically, I already write a proper code, okay, to convert all those things, okay. Basically, all those data field, okay, all those data field has names, okay. So right here, you can see that we can convert a packet, okay, by using the names. And those names already defined in the packages. So as long as you know what the name is. And how do we know which names we have? And there is a very specific function right here. Right here. Okay? For this class is IP, okay? It has several fields, okay? And we extract this field's name in a list so that we can iterate this list to find all the names defined by IP class so that we can obtain all the fields name by using this very simple line, line 2. Okay, it's similar. Okay, it's quite similar for layer 4. Okay, for each TCP. Okay, for this class. Okay, that is TCP class. Okay, we can find its field description and we find its name, and we store this name in a list. Okay, which is called TCP field, so that we can iterate those fields to find this one. To find for this packet, and this packet has a field and its name is right here, right? So we can extract all the field defined in the IP class, in the TCP class, in the UDP class, and use this information to create a table. Okay, the table is right here. Okay, to create a table, so we can have a table like this. And for the first few, those are IP's headers, and of course there are some TCP headers at the right hand side. Okay, so that is okay. So take some time to look at the code I write right here, okay, from line 1 to line 44, to make sure you understand how to construct a table from pcap file. Okay, so that we have a table like this. Okay, so next step is we don't know which field, which column, okay, is useful for us. So basically we just put them right here, put them in the table. Okay, in this table there are several different types of data. For example, that are integers, right? Those are integers. It's quite easy to understand. But there are some text data. As you know, we cannot fit those text data in Orange or in any algorithms, right? So make sure for those text-based data, you have to further to convert those data into integers or decimals. 好吗？中文就是说我们就这样子，反正上面有一堆扣你回家自己看就是我们怎么把封包里面的东西全部都解出来，变成一个表格。好，那可是问题是，封包里面有很多东西是数字型的，那没有问题。那文字型的，你就要想办法，像这个 DF， 它就是文字啊，那你就想办法把这一栏删掉之后，另外再创造一个新的栏，那里面可能就有你自己的编码，比如说如果这一栏是 D 就写1，这栏是 F 就写2，这栏是 DF 就写3，想办法把它换成数字型的。那通常文字型的换成数字型都是 categorize 的，就 categorize。那你们再想办法进 Orange 或者进 Python 的时候，想办法再看看这个栏位要怎么用。Of course, there are some data they looks like integer. However, this is IP address. IP address is not integer, right? It's just a representation of address. So you have to convert those IP address to some other representation. 就是你要把 IP address 换成其他的表示方式，有很多种。比如说，你就不管了，127.28.0.1，如果你知道的话，它其实上对应的一个32位元的整数数字，你就直接把它换成32位元的表示方式就好了。但如果你有一点点 knowledge 的话，你会知道127.28实际上它是一个 class C 的 ABC 啊，对 class C， 对 class B， 它是一个 class B 的 subnet 里面的1号的这个编号嘛，对不对？那你要不要 further 的去把它变成2个 column 呢？一个 column 是说啊，这是属于 class C 的，另外 column 是这个 class C 的prefix 是127.28suffix 是1，那都要看你的 knowledge。走到这边的时候，已经很多 knowledge， 你要自己去编码这些你得到的数字了。好，英文再讲一遍哈。As you know, IP address is not merely a number. Okay, basically, if you basically it is a 32-bit integer. Okay, and we simply just represent it as a 4 numbers. We concatenate them by using dot, but basically it is a 32-bit integer. Okay, so you can represent source address by using a 32-bit integer, or you can represent it in another way. As we know, 172.28 it is a class B subnet. So maybe you can create another column that says, okay, that source address is a class B address. And it is the first address in this class B. Its prefix is 172.28, and its suffix is 1. So basically, those information are extracted from packet directly. However, when you want to analyze this table, you have to do some pre-processing, try to convert the original data to more enriched data representation. Okay, so there are a lot of different ways to represent an IP, and you have to decide which is more proper for you to describe an IP address. Okay. So that is basically like this. So before you before you analyze your data, you have to observe this table, right? So basically, we do a lot of different analysis from the perspective of statistics. Okay, so let's take a look at this one. Okay, we can find out what is the top. What is the source address? What is the description? Describe. We have to do description of this field. So that is the result. Okay. For this column, source. Okay, IP source. Okay, there are 162 IP address. Okay, and only 6 unique IP address as the source address. Okay, the top, which is the largest one, is 172.28.0.2. Okay, and the frequency of this one is 43, something like that. Okay, you can do that on source address, destination address, and so on and so forth, so on and so forth. Okay, and then we can ask some question. Who is the whom to whom the top address is talking to? Okay, so there are 2 other addresses that the top address talk to. Okay, and what is the top address? Using the destination port, the source port, and so on and so forth. Of course, that's you simply just write some code to see those statistic data. Okay, So here is what is the unique source address, what is the unique destination address, okay? And even you can draw a figure to observe the packet you captured, okay? For example, that is the, what is the, okay, source and payload sum, okay? We have 162 packet, right? And we have different sources, but we have only 6 source address. And we can sum up how many packet byte, okay, has been transferred from this source. So as we can see that this guy, okay, 10.1.10.53, it transmits more about 25,000 bytes when we capture our data. Okay, it's a lot. Okay, of course there are some other source and their payload, they're sending payload. Okay, so you can do such kind of things to see the difference between the source address. Okay, and here is the receipt. How many bytes has been received by this 6 unique destination address, something like that. Okay, I skipped some codes right here. Okay, make sure you review those codes at home so that you know how to draw such kind of figures. Okay, these are source port. Okay, there are a lot of bytes has been sent from those source port, and we group those information. Okay, so make sure you understand what exactly this line means. Okay, if you have any problem of reading this code, okay, to understand this code, make sure you check Dataframe. Okay, pandas, that is pandas Dataframe. Okay, you can find the documentation from in the internet. Okay, they teach you how to do Dataframe manipulation. Make sure you are very familiar with Dataframe manipulation, so they can create those data and plot this data. Okay, some other things. What is that? That is destination port. Okay, so we can see that here is the IP address, right? That is the destination port, and here is the payload byte. Okay, among those 162 bytes. Okay, so we can do such kind of things. Okay, so that is just basic statistic and plot. Okay, but however, we have to take a look at the payload, because we believe hackers, okay, use those layer 7 messages, use this payload to attack our services, our network services. So let's take a look at this payload. So most of frequent address is speaking to. Okay, so we have 2 different destination address, and those inbound traffic would like to talk to this destination address. Okay, so here is the okay. Here there is a name, there is a field called payload _row. Okay, so in this package, okay, it automatically helps us to parse the packet, and one of the field is payload row. So you can simply just call payload row to retrieve the layer 7 message of each packet. Okay, so let's take a look at one of the examples right here. Okay, it looks like a HTTP payload, right? HTTP/1.1 and 200. Okay, so it is a HTTP reply, something like that. So basically, if we want to filter out all the HTTP packet, for example, we use the destination port 8080 to help us to filter out all the packet in the original data set. So here we have 60, okay, maybe even more. 98, okay, maybe. Okay, we have even more packet, so that we can only focus on HTTP packet, okay, which is 8080. So that we can, of course, those are IP headers, and I think there will be a lot of different headers at the right hand side which describe the layer 4, layer 7, which is HTTP payload, so that you can use this payload to help us to organize your features. Okay, so of course you can further do something about filtering, which means when we analyze malicious packet, usually we will like those packet has layer 7 payload, because sometimes hackers, they will send you a packet without layer 7 payload, which means nothing is contained in the packet. And since nothing is in the packet, so we believe such kind of packet are only used for probing, which means they would like to know if you have such kind of service or not for probing. Okay, but if they indeed want to hack your server, they have to transmit some malicious payload in their packet. So basically this line, on line 1, that means I would like to filter out packet which has payload. If this packet has no payload, and I will filter them out. Okay, so here's the. Okay, so further we can use this packet to do analysis. Okay, let's stop right here, and we will continue next week. Okay, so we stop right here, and for our midterm, okay, we will announce our midterm collab. Okay, so you make a copy to your own Google Drive and try to answer all the questions on the. You have to write some code to answer those questions. Okay, maybe it takes you 2 or 3 weeks to finish your midterm. Okay, so we will announce it on our website later. So that's it. Okay, we stop right here. Okay, so that's it. If you have any question, please ask in our forum. Okay.